Okay, so good morning, class. Today we will be discussing how to get the roots of nonlinear equations. Okay, this is composed of part 1 and part 2. So today we will be discussing first part of getting the roots of nonlinear equations. Okay, so for your outline, quick introduction of how to find the roots. Okay, or mga iba't ibang type of equations. Okay, what is nonlinear equations? Okay, the first part kasama rin natin yung bracketing or close methods. These are the bisection method and the regular falsi method or the method of false position. Okay, for your next part, next meeting, okay, you will have open methods or the fixed point iteration, the Newton-Raphson method, and the second method. Okay. For your next meeting pala, you will have your first quiz. Okay. Your first quiz will be composed of the complex number and itong bracketing methods. Okay. Sige. For introduction, okay, so many engineering analysis requires determination of the values of the variable x that will satisfy the nonlinear equation. So many engineering problems, okay, especially sa atin, civil engineering, naghahanap ng roots of the equations. Okay? So example, you will also find the theta when maximum deflection. So the maximum deflection given yung meron kang double integration method, okay? So the maximum deflection, nandun yung theta is 0. Okay? So you will find the roots. Okay? So paano ba na-solve yung roots? Gamit yung calculator. Okay? So the values of x satisfy the above equation are known as the roots. Okay? Pag in-equate mo siya sa 0, ang tawag dyan is roots, okay, or the zeros of the functions. Okay, so for the roots, may be infinite, okay, may be finite, okay, may be finite or infinite, okay, may be real or distinct, may be real and repeating, may be complex conjugate, or mixture of the above. Okay, na remember yung complex, okay, remember yung real numbers, okay. So for the illustration, I will give you for consider natin yung fourth order polynomial function. So x raised to 4. Okay. So for this x raised to 4, this equation, x raised to 4 plus 6x cubed plus 7x squared minus 6, 8 minus 8. If you plot this one, meron kang 1, 2, 3, 4. Okay. So every non-zero, single variable degree, and polynomial with complex coefficients has counted with multiplicity. Okay? So exactly, kung ilan yung raise, naka-raise, exactly, nandun yung number of roots. 1, 2, 3, 4. Okay? Another one is yung meron kang 4 real roots, pero yung isang root ay nadoble. So 1, 2, 3 na doble dito and 4. Okay? So 4 pa rin yung real roots. Okay, so you have 2 distinct roots and a double root. Okay. Also, we have 2 real distinct roots and 2 complex roots. Okay, pwede rin yan. Pwede siya na 2 real root, okay, magkaibang root, and also 2 complex number root. Kasi meron siyang, let's say, example of a negative number. Okay. Also, you have the 4 complex roots. Lahat is a complex roots. Okay. So this is also an example of an equation with 4 complex roots. Okay. Okay. So a function may be defined or may be classified as a polynomial and a transcendental functions. So you have you alam niyo na yung polynomial. A polynomial is yung a function raised to n, okay? X raised to n, yan. Polynomial functions yan. What about naman yung transcendental functions? Okay. So for the transcendental functions, we have the exponential function, we have the logarithmic function, we have the trigonometric function, And we also have the hyperbolic function. So recall your algebra, your geometry. Okay? So meron siya iba't ibang function. So for the polynomial function, second order, you all know yung quadratic formula. Okay? So quadratic formula, ganun mag-solve ng polynomial with second degree. Okay, so meron tayo as squared plus bx plus c. So you have negative b plus minus b squared minus 4ac all over 2a. So that is quadratic formula. Okay? So, have you wondered paano ba nagsosolve yung calculator natin? So, greater, kunwari, x raised to something na, x raised to 9, 10. Okay, something like that. For higher order polynomial functions, your calculator, di ba? Iba-iba na yung method niyan. Okay. So, we have the direct methods and we have the numerical methods. Okay? So, first, ito yung itatackle natin, numerical method. So first, we will discuss muna yung direct methods. Okay, paano ba yung direct method, sir? Okay. So direct method, usually ang ginagawa dyan is naglalagay ka lang ng values of x. Okay? Kahit anong value, 0.1, next 0.2, 0.3, 0.4, 0.5, then that hanggang sa maglalagay ka lang, direct hanggang sa mag-equal siya sa 0. Okay? Imagine kung gaano kadami yung ilalagay mo. Okay? So that is direct method. Okay? So as a default, ginagraph siya muna. Okay? Pagka-graph, doon mo malalaman nasaan yung medyo root. Okay? So I would recommend i-graph mo muna yung possible to get an overview of where your roots are found along the functions. Okay? Kunyari, ito yung function, ito yung graph, nandito yung 0, yun. Nagkaroon ka ng graph kung nasaan yung roots mo, na between 100 to 150, okay? Something like that. Okay? So you have the graphical methods. It is kasama rin siya dun sa ibang way. Okay? So by graphically, ipa-plot mo siya. Okay? Doon nga sa direct method, we have the incremental search. Ito yung sinasabi ko na mag-plug in ka ng kahit anong values, may step ka, kunyari step mo is 0.1, 0.2, okay? So from 0.1, next step mo 0.2, 0.3, 0.4, okay? Hanggang mag-0, then after, liliitan mo pa yung step, 0.001, gano'n. So yun yung incremental search. So imagine kung hindi ka nagawa ng program or hindi ka ikaw yung gumagawa, napakatagal paghanap ng roots. Okay? So the values of x incremented from initial value of x1, okay, successively changed in a sign of the function f of x is observed. Okay? If the f of x is real and continuous in the interval from x left to x upper, okay? So f of xl and f of xu have opposite signs, okay? Then there is at least one real root. Ano ba ibig sabihin nito? Yung function daw, kunwari left mo, yung boundary mo, okay? Pag pinag-multiply mo daw is negative value, andun daw yung root mo. Bakit? Okay. Imagine meron tayong dalawang ito. Let's say meron tayong ito yung root natin, 'di ba? So let's say nandito yung XL mo. Okay? Nandito yung XU mo. Okay? So, ito. Yan. Ito. Yan. So, ibaba ko na lang siya. Okay? This one. Ito yung XL mo. First guess. Ito yung ano mo. So, ibig sabihin mo, yung root mo is within XL in the interval XL and XU. Okay? Bakit natin nasabi yon? Sabi niya sa theorem, kapag daw ang the y values of your XL and yung XU, pag pinag-multiply is a negative number, nandun daw yung root. At least one real root. Okay? Bakit? So yung XL mo, say you almost have negative 0.5. Tama? Yung by guess, okay? By graph, we can say f of xl is almost 0.4, negative 0.4. Ayan. Okay? Then yung f of xu, you have 0. Sige, say 0.4 na rin. Okay? Pag pinag-multiply mo siya, you have the negative number, di ba? Okay? So a product mo kapag negative number, yung boundary, so we can conclude that in that boundary, meron kang one real root. Okay? Any questions for that? So ito, helpful to for pag magagawa kayo ng program. Okay? So yun, yung f of xl multiplied by f of xu, kapag negative, then there is at least one real root between xl and xu. Okay? So, kunwari, we will be choosing yung incremental search, di ba? Nag-search tayo, we will be using incremental search. Meron tayong step na ganito, 0.001. Okay? Ang marami siyang problem. Okay? The first problem is if too small. Kapag sobrang liit ng increment mo, say ang increment ng search mo is 0.0001, okay? Gusto mo for at least 4 decimal places yung exactness. Then nag-start ka ng number mo is 1 up to, let's say, up to 2. O napakadami niyan, 1 to 2. So meron kang 1.001, okay? Next 1.0002. Okay, napakarami yan. Imagine 003, okay? That hanggang pumunta ka sa 2. So napakarami ng incremental search mo. So it will be time consuming. Kahit gumamit ka ng program, time consuming kapag gumamit ka ng incremental search na method. Okay? Also, if too large, okay, possibility of missing closely spaced out multiple roots. So yung too large naman, kapag sobrang laki naman ng increment mo, hindi mo mahanap yung roots. Okay? What if yung root pala is 2.00 something? 2.0005, let's say 2.05. Tapos yung step mo lang is 1. Okay? So hindi mo mahanap yung root kasi medyo malalaki yung space mo na ginamit mo na increment. Okay, so yon, hindi mo siya mahahanap. That's also a problem. Okay, so a note, the method can only be used to find only the real root. Yung method na incremental search, magagamit mo lang siya kapag maghahanap ka ng real root. Okay, real. Then, if the graph of the functions touches the x-axis, the function does not undergo a sign convention. Okay? 'Di ba sinabi ko kanina kapag yung f of xl multiplied by f of xu is negative, okay? Nandun yung root. Paano kung hindi negative yung pero nandun siya. Let's say you have this graph, okay? Meron kang ganitong graph. Okay? Then sabi niya, ito yung okay, nag-touch dito. Okay, nag-touch dito na. Ayan, nandiyan yung root. Okay. Tama naman na nandito yung, let's say dito yung XA, nandito yung XL, XU, nandito yung XL. Okay. Tama na nasa between niya, nandun yung root natin. However, okay, yung f of XL ya theory, this theory, hindi mo magagamit kasi this is a positive number, this is a positive number. So pag pinag-multiply mo, a positive number. So hindi mo siya nagamit. So that is one problem. Okay. Another problem, the method may not be able to distinguish between a root and a singular point. Okay. Hindi niya rin mahanap kung yung point mo is a double root. Okay. Naririnig pa ba ako? Am I still clear?
Yes po.
Yes po. Sige. Ayun, that is the problem for the incremental search. Okay. So for the direct method, I see. This one, yung direct method, okay? So, meron siyang propose sila na yung numerical method. So for the numerical method, we will find bracketing methods and open methods. So yung yung numerical method, nahahati pa siya sa dalawa. You have the bracketing and you have the open method. Okay? For this part, you will be first understand what is the bracketing method. Okay, so for the bracketing method, you will base two initial guesses, okay, that bracket the root that are on the other side of the root. Okay, may always work but converge slowly. Okay, for the open method naman, it will involve one or more initial guesses, but there is no need for them to bracket the root. Hindi na natin iba-bracket yung root. Okay, so do not always work, but when they do, they usually converge quicker. So mas madali yung when comparing the time na it takes to find the root between the bracketing open, you mapapansin niyo na mas mabilis yung open method. Okay? So first, we will discuss muna yung bracketing method. Yung term na bracket, binabracket siya. Okay? Ano ba yon, sir? This one. One example of bracketing method is the bisection method. Okay? So bisection method, okay, ang ginagawa dyan, you will find the two guesses, ito, XL and XU, okay, X left, X up. Okay, ang ginagawa diyan, bina-bracket mo siya, ini-enclose mo hanggang mahanap mo yung root natin. Okay, hanggang sa yung pagitan nila, okay, mahanap mo yung root. So that is the bracketing method. Okay, so an important requirement for this method to work is that meron kang two initial guesses encloses the root. May nasa gitna yung root. For the Newton-Raphson method, or another example naman siya for the open method, okay, this method do not share the requirement of enclosing the root, so making them less restrictive in terms of the initial guesses. So okay lang kahit anong initial guess mo, okay, you will arrive to the root. Success of the method does not depend on how close the initial guess is to the location of the root. Okay, so it doesn't matter kung nasaan ka, ano yung initial guess mo dito sa Newton-Raphson. Okay? Kasi it will always arrive to the root. Pero dito sa bracketing method, dapat malaman mo, so you need to have an overview kung nasaan ba yung root para maging successful yung XL and XU mo, yung guesses mo. Okay? So sana i-graph nyo muna yung function. So pag nag-graph nyo yung function, or nag-table kayo, you find dito sa baba negative, dito sa taas positive. So nandun yung root. Okay? So for the bracketing method, we have two known method. We have the bisection method and we have the regular falsi method, or the method of false position. Okay? Next meeting, we will discuss na lang to open method. Okay? So for the first part, for the bracketing method, ang theorem niya dyan, okay, if a function f of x is continuous in the interval a and b, okay, such that f of a and f of b is a negative number or less than 0, then the equation f of x equals 0 has at least one real root in the interval a and b. Okay, so usually if fa multiplied by fb is greater than 0, it implies 0 or even number of roots. Okay, if fa and fb negative 0, it will imply odd number of roots. Okay, it doesn't really matter, basta bracketing method, usually nga fa and fp is less than 0, nandun yung root kapag mga ganito yung graph. Okay? So don't worry, yung graph naman na ibibigay ko is hindi ka mahihirapan na ganito. Na hindi na yung dalawang product is negative, is a positive number. Okay? It's also this one, positive number din. So ayan. So first, we have the bisection method. Okay? So for the bisection method, ang algorithm dyan is a numerical method for estimating the roots of a polynomial functions. Okay, it is the one of the simplest and most reliable, but it is not the fastest method. Okay. Assuming you have the function na continuous. Ito, function continuous. Okay. So ang algorithm ni bisection method, okay, we will find a points A and B. Okay. Maghahanap ka ng point A and B in that graph. Okay. Such that FA multiplied by F of B is a negative number. So we all know it is a negative number kasi nasa baba a negative value, nasa taas a positive value. Okay, tama yung guess ko na A and B. Okay. So after getting the interval A and B, okay, find the midpoint xi. So hahanapin mo yung midpoint. So midpoint is just simply A plus B. Okay? So let's say the midpoint is equals lagi siya sa A plus B all over 2. Midpoint. Okay. Hahanapin mo lang yung midpoint. Then if f of xi, yung f ng midpoint, the value of midpoint is 0, then xi is an exact root. Okay? Else, kapag pinag-multiply mo ulit yung f of xi, f of b less than 0, yung xi mo magiging a, and if yung f of a multiplied by f of xi is less than 0, then yung b mo naman yung xi. So ano nangyari doon? Okay? So for example, nandito yung first midpoint natin. Okay? Nandito yung first midpoint natin. Then imagine nandito yung first midpoint natin. Okay? This is a positive number. Okay? Dito ay negative number. Okay? So sinabi ko kung f of xi times f of b, positive yan, di ba? Positive number, a positive number. So hindi siya wala sa gitna nila yung root. Di ba? Tama, wala sa gitna nila yung root. Okay? Pero kapag yung f of xi, minultiply ko sa f of a, negative siya, sir. Tama. So therefore, nandito sa gitna yung root nila. Yan, nandyan sa gitna yung root nila. Okay? So ganun yung nangyayari dito. Okay? If f of xi multiply by f of f of b, okay? Nangyari dito sa atin, hindi siya positive, hindi siya negative number. Okay? So hindi mo to gagawin. Pero kung ito yung nangyari, f of a equals to f of xi, f of less than 0, then yung xi mo, siya naman yung magiging next na upper boundary mo. So ito na yung magiging b mo again. Then you will find again the midpoint, then we'll check again. Okay? Check again, then ganun. So we will repeat until such time na yung f of xi mo is almost 0 or meron siyang DOA or the degree of accuracy, or we call this also a tolerance. Okay? Let's say ang tolerance natin is 1 times 10 raised to negative 4. Okay? So do you have any questions? Okay. So siguro mas madali kung makikita natin yung paano yung nangyayari. So ganito. Ito. So let's say you have your first guess 50. Nandito naman isa, let's say 200. Okay. After some point, nandito yung nakuha natin first iteration, nandito yung midpoint. Okay? Then nag-check ka ulit. Minultiply mo yung dito, negative, dito negative. Oy, wala dyan yung root, nandito sa kabila. Nandito yung negative, multiply by positive, nandun yung root. Ama, nandun yung root kasi pinag-multiply mo ang negative. Okay? So ito yung magiging upper left boundary ko, ito na yung magiging right boundary ko. Okay? Then find again the midpoint. Okay? Second iteration, find again the midpoint. Then after that, i-check natin ulit. Okay? Nasaan ba sir yung ito positive number, ito negative number. Pinag-multiply ko a negative. Okay? So, nandyan sa gitna nila yung root. So dito na, ito na yung gagawin ko. Ito na yung left boundary, ito na yung right boundary. Okay. So nandito na naman yung midpoint. Okay. Nag-check ulit tayo. Okay, nag-check ulit tayo. Ito, a negative number. Ito, a positive number. Pag pinag-multiply, okay, a negative number. So nandyan yung root. Okay, so next iteration na naman, find the midpoint, etc., etc. Okay, so nandun ka na sa fourth iteration. Okay, did you get the, ito, nag-gets ba? Anyone? Any questions? Sige. Sige, try natin sa problem. Siguro mas madaling maintindihan kapag nag-problem ka na. Okay. So for example, okay, consider natin yung function x cubed plus 3x minus 5. Okay? Sige. I-plot muna natin. Nakikita nyo ba yung sa Microsoft Word? Desmos ko?
Yes po, sir.
Desmos, nakikita nyo?
Hindi po, sir.
Hindi yata. Sige. Dito tayo sa screen. Ayan. Sige, let's try to plot muna yung x cubed plus 3x minus 5. Okay. So, x cubed plus 3x minus 5. Okay. Nakita niyo ba to yung graph?
Yes po.
Sige. Nakita natin na ang root natin is 1.154. Tama? So, pwede nating i-guess na, sige, ano ba yung guess natin dito? Yung guess niya is between 1 to 2. Okay. X cubed plus 3x minus 5. X cubed plus 3x minus 5. Okay. So, yung guess niya is between 1 to 2. Okay, tama naman. Between 1 to 2, nandun yung root natin. Tama? Sige. Let's try na kung paano yung gamitin yung bisection method. Oops. Ayan. So, the first, we have 1 to 2, yung A and B natin. Okay? The midpoint is 1 plus 2 divide 2, so 1.5. Tama? Okay. So, plug in mo yung f of A. So, f of 1, lagay mo dito. So, we have, I think dapat mas maganda may calculator tayo para mas ma-appreciate nyo. Let's solve natin isa-isa. Yan. We have x cubed, okay? We have x cubed, okay, plus 3x, okay, minus 5. So plug in mo yung 1, so solve mo sa 1, you have negative 1. Plug in mo yung 1.5, okay, 1.5, you have 2.875. Plug in mo yung 2, you have 9. Okay. So, sabi dito sa algorithm, hanapin mo yung FA of FB multiplied by, ito muna, check natin kung tama ba yung interval. So, FA multiplied by FB, negative value ba? Okay. Negative 1 times 9 is negative value. So, yes, nasa gitna ng A and B yung root natin. Okay. Next, find the midpoint. Naghanap tayo ng midpoint. Okay. Next, find f of xi or find of f of midpoint. So 2.875. Hindi siya 0, then hindi pa mag-move on pa tayo. Okay? Else, check na natin kung f of xi ba multiplied by fb is negative, okay? Or f of a multiplied by f of xi is negative. So, ito yung mangyayari. Okay? So, tama ba na f of a multiplied by f of x, ito yung negative. Ito hindi ito negative, di ba? Okay? Ito multiplied by dito, ito yung negative. So, therefore, yung x natin, okay, magiging, yung xi natin, ito yung midpoint natin, siya yung magiging upper boundary na natin. Kasi, nandun na yung between 1 to 1.5, nandun na yung root natin. Okay? So ito yung magiging upper. So pupunta siya dito sa upper na to. Oh, yan. Then, kung nandiyan na siya, get the midpoint again. 1.5 plus 1 divide 2, you get 1.25. Okay? So, plug in mo ulit yan dun sa calculator. Okay? So, calculate 1, you have negative 1 pa rin. Calculate 1.5, you have 2.875. And calculate 1.25, you have a positive number. 0.7. Okay. So, nag-check ka ulit. Multiply mo yung FA, FX, or FX, FB. So, FX, FB, hindi siya negative. So, dito tayo sa kabila. Ito. Therefore, we can say na between A and your in your midpoint at the second iteration, nandun yung answer, nandun yung root. Okay, so ito magiging ano naman ulit? Magiging upper boundary ulit. Yan. After that, get the midpoint again. We get the 1.125. This is the function. Yon, nagbago na. Okay, nagbago na. Kasi ito, pag pinag-multiply mo yung -1 sa f of a multiplied by f of x, you have a positive number. Dito na siya magni-negative number. Therefore, okay, ano yung conclusion na pwede natin mangyari kapag ito na? Anyone?
Therefore, yung roots po is between 1 and 1.5.
1, hindi siya 1. Ay between your x and your b. Between 1.125 to 1.25. Okay? So therefore, yung 1.125 mo, magiging a na siya. Ito. Therefore, yung xi mo magiging a. So gaganon siya. Oh. Pumunta dito. Okay? So ito as is. Hindi napalitan. Nagets ba yun? This one. This function. Okay. So yon. Next, ito na yung lower natin, ito yung upper natin. Get again the midpoint. We have this midpoint 1.1875. Okay. Then nag-check ulit. Ito yung mga values of y. Ito ulit. Okay. Then pinag-multiply. Therefore, yung f of a, f of x is negative number. Therefore, yung xi natin, siya ulit yung magiging upper natin. So naging upper limit ulit siya. Ito. Naging b equals xi. Sundin nyo lang to. Itong a equals xi or b equals xi. So hindi kayo malilito. Ito, sundin nyo lang to. Yung if-else condition na to. Okay? So ito, magiging ganito na siya ulit. Pupunta na siya dito. Okay? Then, plug in again the values, negative, positive, positive. Therefore, nandito siya again. So, yung midpoint na nakuha dito, siya yung magiging upper limit. So, ganoon ulit. Okay? Then, continue natin yung ating iteration. Okay? Continue your iteration, verify your iterations. Okay? Until such time na yung degree of accuracy nakalagay dito is 0.001 such that yung f of x is less than 0.001. Nandito ba 0.001 less than pa na ba to? Absolute value ha. Ito, absolute value of f of xi is less than or equal to the degree of accuracy or a tolerance. Tolerance din ang tawag dito of your tolerance. Okay. So, dito ba? Hindi pa po. Kasi 0.001, 20. Ito, 09, hindi pa po. Dito, hindi pa rin. Okay. Sa 8th iteration, hindi pa rin. Okay. Sa 9th iteration, yes, 3 0 na yan. Okay. Therefore, hanggang 9th iteration, your value, therefore, yung roots natin is yung xi. So, 1.154. Therefore, ito na yung roots natin. Tama ba na 1.154? So, check natin yung graph natin kanina. Yes, 1.154. Okay. Any questions for this one? Sige. Susundan nyo lang tong if-else. Ito, para hindi kayo malito. Okay? I-multiply nyo lang lagi yung mga values. Ganito rin yung gawin yung table para medyo okay. Okay? Multiply nyo yung mga values. Then, kapag negative, okay, a equals xi. Pag ito naman, b equals xi. Yan lang. Then, copy yung mga na walang nabago. So, copy nyo lang to. Yung hindi nabago, this one, di ba? Kasi ito yung nabago. Kinopy nyo lang. Ito hindi rin nabago kanina. Yun. So, maybe mas maganda yan kapag ito-try nyo sarili nyo. Mas makikigets nyo. Okay. So, for your homework, ito. Sige. Mas madali ito kapag ginawa nyo. I think ang iteration na ito hanggang 6 lang ata. Okay. Yung tolerance natin is 1 times 10 raised to negative 4. Okay? So ito, sige, you may pass this one kung gusto nyo. Ano ba gusto nyo? Ipasa nyo rin ba to? Sige. Sige, pasa nyo na lang din yung sagot nyo. Pero okay lang kahit ano nyo, yung homework nyo. So, for this one, the answer is 0.5671433. I don't think kung ito rin yung makukuha yung answer. Pero, yes, I think ito nga. Na exactly. Sige. So, for the bisection method, for your homework, write in short bond paper. So, you may pass this on next meeting. Okay, again. So, method bounded by the interval 0, 1. So, the tolerance natin is 1 times 10 raised to negative 4. Okay, ito, huwag nyo nang itindihan to. So, for your own, ano na lang, curiosity. So, write your own version of the bisection method in MATLAB. So, huwag nyo na gawin to ha. Okay. Any
Sir,
question? Okay,
pwede ko
ano yan?
magtanong.
Sige.
Possible po ba na maging negative both products of FAFX tsaka FXFB?
Possible ba na maging negative yung product? Hindi. Hindi.
Isa lang po lagi nagiging negative.
Oo, isa lang lagi.
Thank you, sir.
Sige. Pag mangyayari lang yon kapag ang graph natin is ganito. Yung sabi example ko. Di ba? Sige, pag-aralan natin yung pitfalls. May after this one, mayroon siyang pitfalls this one. Sige. Thank you for your question. So, pwedeng mangyari na hindi parehas negative. Okay? Ang nangyari doon, nasa ilalim lang siya lahat. Pero hindi naman mangyayari sa exam 'yon. Okay? Sa kahit ano, kasi syempre i-assure ko na yung binigay ko sa inyo problem is always ganon. Okay? Pero sa real life, pwedeng mangyari yung ganon na negative. Okay? Ito yung pitfall or yung problema sa bisection method. Okay? That is one of the problem of the bisection method. Kapag yung yung product is a positive number, katulad kanina, di ba? Product niya na ganyan yung function, merong roots dito, ito yung pinili mo na lower and upper boundary, then the product niya is positive. So, hindi mo mahanap yung root, hindi magpo-process yung bisection method. So, one pitfall yon kapag yung product is greater than 0. Okay. Another pitfall kapag double root. Hindi niya malalaman kung double root ba yung root na yon. Okay? Another problem kapag ganito, yung product ng f of xl, f of xu is negative, then hindi niya mahanap yung single and double root. Kasi ito, kapag nag-product ka ulit, nag-midpoint ka dito, sabay xu dito, hindi pinakita. Ayun, wala. So, hindi niya rin mahanap yung double root and yung single root. Then, hindi rin mahanap yung complex root. Then, ito, example nung question mo kanina na, yes, sir, parehas nga siya na negative pero hindi mahanap yung singular point or yung may asymptotic siya. Hindi continuous yung function. So, yes, pwedeng mangyari yung tinanong mo kanina, that is another pitfall for the bisection method. But in the case for your exam, for your quizzes, hindi ko naman ihahayaan na yun yung ibibigay ko. Okay? Sige. For the second method, we have the regular falsy or the false position method. Okay? For the false position method, ang same lang halos sa bisection method, ang naging difference lang is yung xi is hindi siya midpoint na. Meron na siyang ibang formula. Okay. Ganun pa rin, yung f of xi multiplied by fb is less than 0, magiging a equals xi. Kapag f of f of xi less than 0, yung b mo is magiging xi. Same lang din, kapag negative, nandun yung root. Okay. So nandito siya. Ito lang yung nagbago, yung xi. So we will repeat again the step 2 and 3 until such time that yung function of x of xi is less than dun sa degree of accuracy or your tolerance. Okay? So degree of accuracy or DOA stands for yung tolerance natin. Okay. I have a question. Sige, question muna ako. Paano niyo malalaman kung hindi kayo nag-graph? Okay? Paano niyo malalaman hindi kayo nag-graph kung nasan yung interval nyo? Okay? Balik tayo dito sa first problem kanina. Okay. Kunyari, hindi kayo nag-graph sa exam. You have x cubed plus 3x minus 5. How will you find your interval 1, 2? Sige, nakikita niyo ba yung screen? Ako lang, screen pala. Ito. So, I will teach you yung table functions. So, you have table. Okay. Yung f of x natin is equals to x cubed plus 3x plus 3x minus 5. Nakuha niyo ba to? Meron bang ganito sa calculator niyo? I think meron naman. May table naman dyan, di ba? Sige. Then equals nyo. G of x is wala. Huwag nyo nang intindihin yan. 0 lang. Okay. Yung start nyo, let's say we have 0. Yung start natin. Nag-guess ka lang. Hula mo na siguro between 0 to 5 to. Sige, 0 to 5. Okay. Okay. 0. Sige, 0. Example muna. Between 0 to 10 siguro. Sige, 0 to 10. End natin is 10. Then yung step natin muna is 1. Okay? Therefore, yung f of x mo, tingnan mo dito, negative 5, negative 1, negative 9. Okay. Uy, nagpalit dito sa negative nagpalit yung sign between x equals 1 and x equals 2. Nagpalit yung sign. You have negative 1, we have 9. Nagpalit na yung sign, di ba? Therefore, nagpalit yung sign, nandun yung root natin. So, between 1 to 2. Check, between 1 to 2. Gets ba yun?
Yes po.
Yes, okay. Example lang yun kung hindi kayo nag-graph. Okay? Actually, makukuha nyo rin yung roots dito eh. Up to 3 decimal places. So, ganito ang gagawin din doon. Kunwari, board exam, wala kayong 991EX. Ganito yung problem namin dati. So, walang 991EX. So, walang ship solve. Okay. So, table natin, di ba? Nag-table tayo kanina. Nalaman na natin na 1 to 2, di ba? Ay, nawala na pala. Sige, nalaman natin na 1 to 2. Ito yung incremental search method. Nalaman natin na 1 to 2. So, ngayon, magbabago na naman tayo. Zero mo lang to. Wala. Sige, magbabago naman tayo between 1 to 2. Then yung step mo naman is 0.1. So ang ibibigay niyan, 1.1, 1.2, 1.3, 1.4, 1.5. Yan. So nagtingin ka ulit. Ayun, between 1.1 to 1.2 nagbago yung sign ng f of x. Therefore, yung next step mo is 1.1 to 1.2. So, etc. etc. Hanggang sa mag-arrive ka into 3 decimal places, you get 1.154. So, ganun yung ginagawa rin sa board exam kapag wala kayong roots. Wala kayong ship solve. Sige. Balik tayo dun sa regular fallacy. Masyado bang mabilis?
Okay lang po, sir.
Okay. For the false position method or the regular fallacy, ito na nga, same lang, iba lang yung xi. Iba yung pag-solve ng xi. You have this formula. A multiplied by f of b minus b multiplied by f of a all over your f of b minus f of a. Okay. So, try natin dito. Okay. Same equation. x cubed plus 3x minus 5. Ang guess niya, the interval is between 1 equals 1, b equals 2. Then a degree of accuracy of 0.001. Okay? So, ganoon lang din. Plug in mo lang 1 and 2. Okay, 1 and 2 muna. Plug in mo yung f of a. You have negative 1. Sige, ilagay na rin natin para makita niyo. Sige, x cube plus 3x minus 5. So, solve, calculate 1. Nakikita ba? Okay, nakikita naman. Sige, 1. You have negative 1. Okay. FB, kasi wala ka pa nito, di ba? Sinasolve mo pa lang yan. Then for negative f of b, so 2. Calculate 2, you have 9. Okay. So meron ka na nito at meron ka na nito. Negative 1 and 9. Then ilagay mo siya dito sa formula. Okay. Ano ba to? A. So 1 times f of b, 9. Okay. Minus b, 2, f of a, negative 1. Okay. Divide mo siya ng f of b minus f of a. So 9, 9 minus negative 1. So you have 1.1. Okay. Then check mo again. F of a multiplied by f of x, positive. So wala dyan. F of x multiplied by na f of b, nandyan. Okay. So therefore, ito yung magiging lower limit mo, ito yung magiging upper limit mo. So ganun, pumasok doon. Okay. Dito lang yun na. If f of a is multiplied by f of xi less than 0, then yung b mo is xi, then if f of xi multiplied by f of b is less than 0, then yung a is equals to xi. So dito nangyari yon. A equals to xi. Kaya ang nangyari, na pumasok doon yung xi mo, naging a na siya ngayon sa next iteration. Then copy, okay, solve again f of a and f of b. Okay. Then fill in the formula again, then you will arrive yung x natin na ganito. Okay. After that, check again yung pag pinag-multiply ba is positive or a negative. Pag multiply mo, hindi siya dito, dito siya. Okay? So, therefore, yung xi is equals to a. Okay. Pasok ulit doon. Then, pasok ulit to, pasok ulit to. You will get this one, you will get this one. Then, check again the, pasok ulit dito sa xi. You will arrive 1.14. Okay. So 1.14, sinolve mo to, negative 0.004, 044. Check mo yung degree of accuracy, 001, hindi pa po pwede. Mas malaki pa siya. Okay. So tuloy ka ulit sa iteration. You have, chinek mo to, positive, chinek mo to, minultiply mo, negative. Okay. So therefore, ito papasok doon again. And ito, copy lang ng copy. Okay. Then after that, solve again the f of a, solve again f of b, then plug in the formulas. Okay. Plug in mo yung formulas, you have ito. Okay. Then check mo ulit kung pwede na ba sa degree of accuracy. Plug in mo dito, 0.015. Mas malaki pa siya compared dito. So hindi pa pwede. Tuloy ka ulit. Absolute value ha. Okay. So tuloy ka ulit. Pasok mo to, solve mo to, then you will find na dito ulit siya negative sa product nitong dalawa. So gaganto ulit siya sa fifth iteration ha. Okay, after fifth iteration, you have f of a, you have again f of b. Then after that, solve the xi. Okay, solve mo yung xi. Then after that, solving xi, solve for the f of x. 005, 001 yung degree of accuracy. So hindi pa po pwede. Okay? So hindi pa pwede. So move on for the next iteration. Then check mo ulit. Dito ulit siya nag-negative, di ba? Pasok mo doon. Okay. Yan again. And check f of a, check of fb. Okay? Then, plug in yung xi. Okay? Get this one. Then after that, get the f of xi, 0018, 001. Hindi pa pwede. Okay? Tuloy ulit sa the next iteration, 7th iteration. So to move on for the next iteration, check again f of x multiplied by f of b. Sila yung nag-negative. Then therefore, papasok ulit doon. Okay? After that, check the f of a, f of b, then solve again xi. Okay? Then solve again f of x. Pwede na ba? 0006, 001? Yes, pwede na. Degree of accuracy is pasok. Okay? Therefore, we will choose 1.154 for the roots. Okay? Okay? Therefore, roots. Because, makita nyo dito, because absolute value of 0.0006, yan, negative 0.006 is less than 0.001. Okay. Any questions?
Sir, pag magpa-plug in po ba ng ano, ng
No.
sa yung sa FA o sa FX po,
Okay.
yung ano po ba yung decimal places, dapat po ba buo or pwedeng up to kunyari 5 or 6 lang?
Mas okay kung buo eh.
Okay po sir. Thank you.
Kasi kapag yun nga yung sinabi ko, yung na remember yung accuracy and precision, kapag nagra-round off ka kasi dito, mababago siya. Mababago na yung roots mo. Okay. So as soon as possible, sige, pagdating sa exam, i-write ko kung ilang decimal places yung ita-type nyo. Ha? Let's say sabihin ko na lang use all 8 decimal places. Ganyan.
Okay po. Thank you sir.
Sige. Any questions? Sige, para hindi kayo mahirapan. Medyo marami pala yung susulat eh. Pero for your homework, sulat nyo ha. You have plenty of time. Nagets mo? Narinig ba yan?
Yes
No.
po.
You have plenty of time. You have 1 week. Kasi madali lang yan. Ito sinabi ko 5 iterations lang. So given for the homework, again, x raised to 10 minus 1 in the interval 0 to 1.3. Then compare yung bisection method and regular fallacy method after 5 iterations. 5 iterations lang. Gagawin nyo to in regular fallacy and bisection method at 5 iterations lang. Okay. So then compare, make a conclusion. So dito sa atin, so ano yung conclusion na nakita natin? Na at this function, x cubed plus 3x minus 5, mas mabilis na solve yung roots using regular fallacy compared to the bisection method. Kasi hanggang 7th iteration lang, nakuha niya na yung roots. Naging degree of accuracy na 0.001. Okay? While sa bisection method, you have 9 iterations. So 9 iteration, nakuha niya pa, doon niya lang nakuha yung roots. So medyo mas mabilis yung regular fallacy in that function, x cubed plus 3x minus 5. So any questions? Medyo maaga pala, no? So pwede nyo nang gawin yung activity nyo ngayon kung gusto nyo. Okay? Kung may question kayo, pwede nyo akong email agad. Then we will serve as your review na rin. Sige. Pwede nyo nang upuan to na pagsosolve. You have 1 hour for these questions. Okay. Hanggang 10 ba to? Sige, hanggang 10. Okay. Any questions for ano? Okay. Sige. I will stop sharing na and stop share. Stop recording. Okay.